Okay, now let's discuss the second partial exam. Problem 1. Solve each equation. We have a logarithmic function with base 5 of x plus 2 and plus log 5 of x minus 1 is equal to number 2. All right, so logarithmic function, logarithmic function has a property that the log a of m plus log a of n is equal to log a of m times n. Okay, so we just follow the rule to have log 5 of x plus 2 times x minus 1 is equal to number 2. And then log a of b is equal to c. By definition, it means b is equal to a to the c's power. So x plus 2, x minus 1 is equal to 5 squared. All right, let's just solve this quadratic equation. This is quadratic equation. It says x squared plus x minus 2. You expand the left side. Right side is 25. And then x squared plus x minus 27 is equal to 0. Well, this is a general quadratic function, so you have to use the root formula. So x is 2a negative b plus or minus square root of a b squared, b squared 1, minus 4ac. All right, so it's a negative 1 plus or minus square root of what? So 4 times 27, 28, 108. Plus 1. Here, minus is plus. So it's a 1 plus 108. It's 109 over 2. But this one, you have two solutions here. These two solutions are the solutions of a quadratic equation, but they are not. They may not be the solution of the original equation. The reason is that we need x plus 2 greater than 0, because the domain of a logarithmic function is from 0 to infinity, and x minus 1 is greater than 0. So you can check that x equal to negative 1 minus square root of 109 is not a solution. This is negative number. Minus 1 is still negative, so this is not solution. So there's only one solution. We have only one solution. What is that? It's a x equal to negative 1 plus square root of 109 over 2. Okay, just plus, no minus. Okay, second one, 3 to the power of 2 minus x is equal to 3 to the power of x. This one is a simple function, a simple equation, because a to m is equal to a to n. Check here, you have the same base. It's correct if and only if m is equal to n. Okay, so you only need to let 2 minus x equal to x. 2 is equal to 2x, then x is equal to 1, and that's it. The domain of an exponential function is from negative infinity to positive infinity. All numbers are accepted, so this is a solution. All right, so problem 1. Problem 2, we have the linear speed equal to the angle speed times the radius. Okay, so the angle speed, you check here, it says 135 degrees per second. You must change this to be, what's this? This is a 3 pi over 4 radian per second. When you get the linear speed equal to angle speed times the radius, this must be the radian. You see here, you use radius, then you need the radian. So it's a 3 pi over 4 times the radius. What is radius? 3-foot rope. So it's 9 pi over 4 it's supposed to be feet per second. Okay, so the answer is 9 pi over 4 feet per second. In this formula, you must use radian. You cannot use degrees. All right, this is problem 1. The problem 2. 3, we have two parts. One is S, arc length. What is arc length? This is arc length. This is R. This is a theta. S, the arc length, is equal to R theta. Okay, so R, what is R? R is 4 inches. Theta is 150 degrees. So check here again. Whenever you multiply a quantity with angle, you should use radian. 150. What is 150? It's a 6. 5 pi over 6. It's a 5 pi over 6. So you're going to use 5 pi over 6, and then it's a 10 pi over 3. So the arc length is 10 pi over 3. Arc length is 10 pi over 3. And the area, the same graph, angle theta, radius, and this area of this pizza, area is 1/2 r squared theta. 1/2 r squared theta. Again, this one you should use the radian. So it's a 1/2. R is 3 meters, so it's a 3 meters squared. Theta is 3 pi over 5. You already have 3 pi over 5. So you get 27 pi over 10 is supposed to meter squared. The unit is meter squared. This is inches. Well, it doesn't matter you write the units or not, but it looks like this. Okay, whenever you multiply the angle by the radius, you're supposed to use the radian. All right? Problem 4. We have an angle between 0 degree and pi over 2. Okay, it's an acute angle, and secant of theta is 5 over 2. We're looking for sine. Find the sine. Secant theta, you see here we are familiar with sine cosine. So secant theta is 5 over 2, so cosine theta is 2 over 5. And theta is between 0 and pi over 2. All the trigonometric functions are positive, so sine theta is equal to square root of 1 minus cosine theta squared. Okay, this formula comes from that sine square plus cosine square is equal to 1. You move cosine theta to the right side and take square root. It's positive square root. So it's a square root of 1 minus 5 over 2 squared is 4 over 25. So it's a square root of 21 over 25. You can leave it like this, or you can just write it like square root 21 over 5. All right? Okay. 5. Find the exact value. 1 minus cosine pi over 6 squared plus cotangent pi over 3 squared. Okay, cosine pi over 6 is square root of 3 over 2, and cotangent pi over 3 is square root of 3 over 3. It's just test of your memory. You have to get the right number. So it's 1 minus this quantity squared is 3 over 4. This quantity squared is 1 over 3. It's a 3 over 9, 1 over 3. So it's 1 over 4 plus 1 over 3 is 7 over 12. And second, 2 plus cosine 45 degrees squared minus sine 45 degrees squared. Okay, so cosine 45 degree is equal to square root of 2 over 2. Sine 45 degree is square root of 2 over 2. So this is a 2 plus 1/2 minus 1/2. Plus 1/2 minus 1/2 is just 2. Right? So problem 5. Problem 6. Problem 6, we are looking for the remaining 5 trigonometric functions of theta. Sine theta is equal to negative 4 over 5, and theta in quadrant quadrant 3. Quadrant 3, check there. This is all trigonometric functions are positive. Sine is positive. Tangent is positive. Cosine is positive. As tac, right? So in the third quadrant, sine is negative, cosine negative, tangent is cotangent positive. So here you will get a cosine theta is equal to negative square root of 1 minus sine theta squared. Because cosine is negative in the quadrant 3, and this formula still come from this basic identity. Okay, so it's negative square root of 1 minus negative 4 over 5 squared. Negative square root of 1 minus, this is a 16 over 25. It's a 9 over 25. It's negative 3 over 5. So cosine is negative 3 over 5. You have sine, you have cosine, then tangent theta is sine over cosine. It's negative 4 over 5 over negative 3 over 5 is 4 over 3. See? It's positive. And then you're going to flip sine, cosine, tangent to get the cosecant, secant, and cotangent. So it's cosecant theta is the reciprocal one. The reciprocal of sine is negative 5 over 4. Secant theta is negative 5 over 3. Here, you flip it. And the cotangent theta is 3 over 4. You flip this one. So you have 1, 2, 3, 4, and 5. 7. Problem 7. We have y is equal to negative 4 over 3 cosine 2 over 3x minus 2 over 3. So the amplitude is absolute value of negative 4 over 3. It's just 4 over 3. Amplitude, we just ignore the sign. And period is 2 pi over 2 over 3 is equal to 3. Over 2 over 3 means you multiply it by 3 over 2. So cancel 2, you get 3 pi. And that's it. Okay, problem 8, we're going to again test the memory and plus a little bit tricks. Okay, so let's check here. Tangent has period pi. Remember, tangent, its period is pi. So 9 over 4 is like 2 pi plus pi over 4. 2 pi is 8 over 4. So, and the tangent is an odd function. You can move this negative sign forward. So first you move this negative sign forward. You will get 9 pi over 4. And 9 pi over 4 is 2 pi plus pi over 4. 2 pi, their period, the multiple of the period. So you ignore it. Right? And then tangent pi over 4 is 1 with negative sign. It's negative 1. Sine negative 7 pi over 8. Negative sine pi over 8 is negative 2 pi plus pi over 4. Remember, 8 pi over 4 is 2 pi. 8 pi over 4 is 2 pi. So you almost have negative 8 pi over 4, and you add pi over 4. So it's a sine negative 2 pi plus pi over 4. And any multiple of 2 pi is a period of sine, so it's equal to sine pi over 4. Sine pi over 4 is square root of 2 over 2. Cosecant negative 45 degrees. Cosecant is 1 over sine. Sine is an odd function, right? So you move this negative sign forward. Sine 45 degrees is square root of 2 over 2. You flip it, it's negative square root of 2. Or you write negative 2 over square root of 2. These two are the same thing. Okay, it's a negative square root of 2. Cotangent negative 135 degrees. Okay, remember pi is 108, so it's a cotangent negative 108 degrees plus 45 degrees. And this is again period. Tangent, cotangent, they have the period 180 or pi. This is a period, you ignore it, it's a cotangent 45 degree. Cotangent 45 degrees is 1. So you have 1. Okay. Problem 9. Problem 9, we're trying to graph 2 sine 1/3 of x. At least the one period. Use a key point method. All right. Okay, so what we are going to let 3x be 0, 3x be pi over 2, 1/3 of x be pi, 1/3 of x is 3 pi over 2, and 1/3 of x is equal to 2 pi. That's a 5 key point. So you will solve it. X equal to 0, x equal to 3 pi over 2, x equal to 3 pi, x equal to 9 pi over 2, x equal to 6 pi. Okay? Okay, now let's try to sketch it. 0, 3 pi over 2, 3 pi, this is a half. 3 pi over 2 is a half of between 0 and 3 pi. These two, 9 pi over 2 is a midpoint between 3 pi and 6 pi. So this is 6 pi. This is 3 pi. 3 pi over 2. 9 pi over 2. All right? And when x is 0, 1/3 of x is 0, sine 0 is 0. When x is 3 pi over 2, 1/3 of x is pi over 2. Sine pi over 2 is 1 times 2 is 2. So you put label 2 here, then you have this. And 3 pi, you will get 0, sine pi is equal to 0. You see, x is 3 pi. 1/3 of x is a pi. Sine pi is 0. So if you sketch it, it will be like this. So you should label those 5 key points. This is negative 2. And also plus or minus 2. Right? So that is the discussion. If you have any further questions, you can send me email. Okay, let me present them again. The first page, first 2 problems. Problem 3, 4, and 5. Six, 7, 8, and problem 9. Okay, thank you.